All right, hi everybody, and welcome to 3.1.1. So chapter 3, we're going to be doing a lot of solving different types of equations, and we are going to look at many ways to solve equations. In fact, if you look down here, we're going to solve this same equation 3 times and using 3 different strategies. So the good thing is we may not all approach a problem in the same exact way, but that doesn't mean anyone's doing it necessarily wrong. We just might have different approaches. So I'm going to show you 3 different strategies, and we'll take a look at each of those strategies, and you can start deciding which one works for you depending on what type of equation you're solving. So the first strategy is rewriting. So rewriting an equation in the process of solving, and we'll look at an example of that soon. The second one is looking inside. So looking inside an equation or part of an equation. And the third strategy is undoing, and that's probably the strategy you have probably the most experience with in terms of undoing certain operations. Undoing. So we're going to look at each of these. Like I said, we're going to solve the same equation 3 times. So in this problem, we're going to solve 3 times this equation by first rewriting. So rewriting would just literally be rewriting it, something that has the same value or meaning as what we're looking at. We're just going to write it a little differently. So in this case, rewriting this would be rewriting x plus 3 squared as what that actually means. So something squared means you're multiplying by itself. So x plus 3 squared would be x plus 3 times x plus 3. And then minus 5 equals 11. So we're rewriting this. Now at this point, again, I would multiply this out or distribute it. So as I distribute this, I'm going to do x times x, which is x squared, plus x times 3, which is 3x, plus another 3 times x. So I have 3x plus 3x, which is 6x, and then 3 times 3, which is 9, minus 5 equals 1. So if what I just did is throwing you off, you may be more comfortable doing that distribution with an area model. So I will put that area model on here. I'll have to move it when I continue. But when you have x plus 3 times x plus 3, you can break that down with this area model. So x times x is x squared. X times 3 is 3x, this x times that 3 is 3x, and then 3 times 3 is 9. So that's where I get my x squared plus 3x and 3x, so that's my 6x plus 9. So if this area model works better for you, definitely go through that process if just the plain distribution that I did is confusing. Okay, so now I can start combining like terms. I've got the 9 minus 5. And I just lost my blue pen. Okay, so I've got x squared plus 6x plus 9 minus 5, so plus 4 equals 1. And now I can... Okay, wow, I just realized that's an 11, not a 1. No problem. So now I can subtract 11 from both sides, and I have 4 minus 11, which is negative 7. Okay, so let's see my final quadratic here. So it would be x squared plus 6x minus 7 equals 0. Now to solve this, I'm looking at a quadratic, and here I would factor. So to factor, again, I would use a, let's see, we'll use a diamond, negative 7, and needs to add to 6. So I need 2 numbers that multiply to negative 7. That's my only options are 7 and 1. But since I want it to add to 6, it would be positive 7 and minus 1. So positive 7, negative 1, and that's how I'm going to factor. X minus 1 equals 0. And then I'll get my 2 solutions for 0, which would be negative 7 if x plus 7 equals 0. Or x minus 1 equals 0, so x would equal, negative 7 or 1. Okay, so again, this is rewriting because I literally rewrote parts of this equation as I began solving, and then I ended up factoring. So now let's look at the looking inside. So looking inside, I actually like to think of it as like taking a step back and just thinking about what this is saying. So I have this right here, -5 equals 11. So thinking about that, this whole piece, x plus 3 squared, this whole piece right here that I'm boxing in, when I subtract 5 from it, it must equal 11, which means, the only number I can subtract 5 from and get 11 is 16. That means this whole piece has to equal 16. So I'm going to start by writing that. This is kind of like the looking inside piece of it. So x plus 3 squared has to equal 16. And then you can look inside and think about the only number we can square to equal 16 would be 4, or the only two numbers I should say, but I can also square -4 to get 16. So that's the looking inside part, is just kind of thinking like, okay, this chunk right here has to be 4 or -4 because I'm squaring it and getting 16. So thinking about what an inside value of a part of a function has to be. So x plus 3 can either equal 4 or x plus 3 can equal -4. So if you think about it, the way I'm approaching solving this already looks way different than this process over here, because I'm just thinking about, okay, well, if I'm subtracting 5, I've got to be subtracting it from 16. And if this squared is 16, then it could only be 4 or -4. And then look what happens when we continue solving. Subtract 3 from both sides right here, and 4 minus 3 is 1. Subtract 3 from both sides right here, and -4 minus 3 is -7. So I have arrived at the same answer. So here was my answer before. It just took a little bit longer to get there. Here, this looking inside, or taking a step back and kind of thinking a little bit harder about what this equation is saying, can really save you some time. But the great news is you guys can choose the strategy you're using. And there's no strategy that looking inside is no more or less valid than rewriting. The last one we're going to see is undoing. And like I said, this one's probably the one you've had the most practice with, because we're just trying to reverse all of the operations we see happening to x. So my goal is to get x by itself right now. Right now it's adding 3, then squaring it, then subtracting 5. And we're going to undo everything that's happening to x in the reverse order. So right now the first thing I would do to start getting x by itself is undo this -5 by +5 on both sides. So add 5 to both sides, and I would get x plus 3 squared equals 16. The next thing is I need to undo this x plus 3 squared. So to undo squaring something, that would be finding the square root of it. So I would take the square root of both sides. The square root of x plus 3 squared is just x plus 3. And the square root of 16, now be careful about this, because when I take the square root of 16, I get the two possible roots of plus or minus 4. So that means x plus 3 could equal +4, or x plus 3 could equal -4. And then I would subtract 3 in each of those separate situations and get 1 and -7. Again, same answers, not a surprise, but a little bit of a different approach with the undoing, and that's probably the more traditional way of solving. Looking inside is definitely one of the less traditional, but equally as valid. And then rewriting, again, something you've seen a lot of. It takes a little more steps in this example, but let's continue forward here. Okay, looking at this example, we have fractions involved, and now we've called the method I'm about to do here fraction busters, and that's just another way of rewriting it. So let's solve this equation while we identify the strategy. So the first thing I would do in trying getting rid of some of these fractions would be to multiply every single thing by 4. So I'm just addressing this first fraction here, but I have to multiply everything by 4. In doing so, my first fraction now is no longer a fraction. So the 4 over 4 cancels, and I have x minus 5 plus 2 times 4, which is 8 over 5, equals 9 times 4, which is 36 over 10. Now I notice that this 5 and 10 are both, if I choose 10, I'll kind of deal with the 5 as well. I also want to identify the strategy that I'm using here. So right here, I just use the rewriting because I just rewrote it. It's a different equation. It looks different, but it's kind of saying the same thing. I've just written it differently. Now I'm going to deal it, like I said, with that 10. So I'm going to multiply this by 10. I'm going to multiply this by 10. And I need to be careful to multiply everything by 10, especially this x minus 5. So I can't forget about multiplying every single thing I see by 10. Doing that, I will distribute the 10 here and get 10x minus 50 plus 8 times 10, which is 80 over 5 equals, now this is convenient because the 10 over 10 cancels and I just have 36. So now again, this is just another rewriting. So really the whole strategy on this one is rewriting. Next, I would start simplifying wherever I can. So this 80 over 5, that's 16. So I can do 10x minus 50 plus 16 equals 36. I'm going to have to come up here because I need a little more space. Now, negative 50 plus 16 is negative 34, so I'm going to write that. 10x minus 34 equals 36. Now I can add 34 to both sides. 36 plus 34 is 70, and divide by 10. So x equals 7 over 10, or 70 over 10, which is 7. So I did rewriting, and then at this point right here, I was just undoing. Again, these are strategies we've used many, many times. We're just kind of putting a name to the different possible ways we can solve some of these problems. So let's look at these next examples, and then we'll be done. All right, looking at number 1 here, I see something similar to what we saw in problem 3-2 above, x plus 4 squared, where we rewrote this at first by multiplying that out. But I also noticed that strategy also took a little bit more time than the others, so I'm going to approach this a little differently, and I'm going to undo what I see happening to x. So the first thing I can undo, that I can't address all this stuff happening to x until I get rid of this 6 first. So the first thing I'm going to do is subtract 6 from both sides, and then continue undoing. So that'll be 3 times x plus 4 squared equals 33 minus 6, which is 27. Now at this point, you might look at this and want to distribute this 3, but we can't because it's being squared first. And when we think of order of operation, PEMDAS, parentheses, exponents first, then multiplication. So we can't multiply this 3 through. But since that 3 is being multiplied by that whole thing, we can divide both sides by 3 right now, which might not be a step we've typically done in the past, but this is the next step in undoing this. So as I divide by 3, that 3 cancels out with the 3 in the denominator, and I'm just left with x plus 4 squared on the left-hand side. And 27 divided by 3 is 9. So now I see this quantity squared equals 9. How do I undo squaring something? And that would be taking the square root of both sides. So now I can take the square root of both sides. And when you take the square root, you need to be really careful to consider both the positive and negative root on the right side. So we have x plus 2 on the left. The square root of x plus 2 squared is just x plus 2. And the square root of 9 is either 3 or negative 3. So you have to remember those two possible answers. So that gives us our two final equations would be x plus 2 equals 3 or x plus 2 equals negative 3. So subtract 2 from both sides, I get x equals 1. And subtract 2 from negative 3, and I get x equals negative 5. So there are my two solutions. I never actually had to multiply this out because I ended up taking the square root. You could have looked at this a different way. Like I said, you can choose different strategies and still land with the same answers if you're doing the math correctly. Taking a look at number 2, so I have -3 square root of 2x minus 1 plus 4 equals 10. Again, this is one that I would also just apply this undoing strategy. So I would begin this problem by starting to think about how to eventually get this x by itself. A lot is happening to it. Multiply by 2, subtract 1, square root, multiply by -3, and then add 4. So the first thing I have to get rid of is this plus 4. So subtract 4 from both sides, and we end up with the equation -3 square root of 2x minus 1 equals 6, since I'm subtracting that. Now, you can't distribute something from the outside of a root to the inside of a root, but I can't undo this 2x minus 1 yet until I deal with the square root, but I can't deal with that until I get rid of this -3, which is being multiplied by the square root. So what I need to do is divide both sides by -3. It cancels over here on the left, leaving me with the square root of 2x minus 1 equals 6 divided by -3, which is -2. All right, so now that I've got the square root by itself, I can undo the square root. And remember, undoing a square root would mean I have to square both sides. So when I square both sides, the square root of something squared just leaves you with whatever was inside of that square root. And -2 squared is +4. So now I'm going to add 1 to both sides. 2x equals 5, and divide by 2. X equals 5 over 2. So we arrived at that. So if we're putting a name to that, we were undoing each step one at a time. All right, looking at number 3. So this one is one that I would, before I just jump right into it, there's more than one way to approach it. But I see 3 plus a big chunk of stuff equals 5. So the only number I can add to 3 to equal 5 is 2. So this whole thing right here, 10 minus 3x over 2, has to equal 2. You can also arrive at that simply by subtracting 3 from both sides, which is the first step if you were undoing it. Or you can, again, think of it as kind of like that looking inside where that whole thing, that whole fraction would have to equal 2. So subtracting 3 from both sides, we would have 10 minus 3x over 2 equals 2. And now I've just got a pretty simple equation that I can solve. I do have a fraction, so we can consider fraction busters, multiply by 2 on both sides, and that 2 over 2 goes away, and I'm just left with 10 minus 3x equals 4. Subtract 10 from both sides. So now I'm undoing what's happening to x. And I get -3x equals 4 minus 10, which is -6. Divide by -3. And I have x equals -6 over -3, which is 2. Okay. All right, final problem here. Okay, so we have a square root in this, or an absolute value, not square root. So we have not really spent a ton of time solving absolute value equations. But if we understand what absolute value does, which is calculates distance from whatever's inside there to 0, we'll be able to handle this. So the first thing I'm going to do is divide by 5. So again, these absolute value bars also act as parentheses. So since 5 is being multiplied by all of that, I can undo that by dividing both sides by 5 first, so that I have that absolute value expression by itself. 2x minus 6 equals 2. So the absolute value of 2x minus 6 equals 2. Think about what absolute value is doing. It means whatever is on the inside of this is exactly 2 away from 0. Well, what does that tell us about 2x minus 6? It has to equal 2. It's 2 away from 0. So it could be either 2 or it could be -2. So we're using an understanding of what absolute value is measuring to conclude that this whole thing has to equal either 2 or -2. So the only two numbers that I could take the absolute value of and get 2 as an answer are positive and negative 2. So that allows me to move forward and say, okay, well, 2x minus 6 either has to be positive 2 or 2x minus 6 is negative 2. Those are the two only possible ways that this equation is true. So from these two possible outcomes, now I'll just solve them. So solving this one first, I've got 2x. I'm going to add 6 to both sides, so 2x equals 8, and divide both sides by 2 to get 4. Or on this second one over here, add 6 to negative 2. Negative 2 plus 6 is 4. Divide both sides by 2, and I get 2. So I've got two answers, and you'll find that with absolute value equations, you will get two answers, because once you have that absolute value by itself, you're going to have, your answers can only be one of two things, the positive or negative of whatever the answer on the right side is. So hopefully this helps. What I'm going to have you guys do next is flip your paper over. And I have 4 problems here for you. So I'm not super concerned about, I'm not going to be grading you on naming the correct strategy. Like I said, there's more than one way to think about these problems. So what I care more about is that you're solving the problems, not necessarily which strategy you're using, but it helps to see these different strategies so that you can look at a problem and approach it more than one way. And that, I think, helps, because we all look at things a little bit differently sometimes. So you can use whatever strategies you want. I want you to solve these 4 equations to the best of your ability, and we will grade them together in class when I see you next. Alrighty, see you then.